This is section 11.3, geometric sequences. Here's a geometric sequence. The difference between geometric and arithmetic is that there is a common ratio with geometric, whereas you could divide the second term by the first term and get a value. Third term by the second term, get the same value. Fourth term by the third term and still get the same value. It's like multiplying to get to the next term. That's our formula. A sub n equals A r n minus 1. A is really the first term. Write the first four terms in the nth term of this sequence. Well, the nth term, 2 times 3 to the n minus 1. That's our nth term. Our first four terms comes out to be, you would plug in 0, 1, 2, 3, 0, 1, 2, 3. So 2, 6, 18, 54, our first four terms. Then we have this sequence, 2, negative 10, 50, negative 250. They tell you it's a geometric sequence. The first term is 2, r is negative 5. The nth term, we just need to write the formula. Oops. You should put your negative 5 in parentheses since it's to an exponent and it's a negative number. For this next one, what do you do to 2 to get to 8? Well, you times by 4. What do you do to 8 to get to 32? Times by 4. Make sure you check them in your sequence to make sure it truly is geometric. So our first term is 2. Our r is 4. So our formula is 2 times 4 to the n minus 1. Finding terms, finding the eighth term. Well, we should probably write a, well, you could keep going with this, like to get from 7 to 42 times by 6, to get from 42 to 52 times by 6. So you could keep going, do the next 5. Or we'll write a formula. The first term is 7, r is 6, so a sub n equals 7 times 6 to the n minus 1. So if I want the eighth term, I'm going to plug 8 in for n. This comes out to be 1,959,552. Here we have the third term is 75/16. And the sixth term is 9,375 over 1,024. We want to find the fifth term. I'm going to use this to get to the sixth term. We'll do the third term times our r, whatever it may be, 3 more times, right? Because 6 minus 3 is 3. So we're going to plug this stuff in. So here we get that r cubed is 125 over 64. We're thinking about things to the third, what to the third, and what to the third would give us, what fraction would be 125 over 64, and this is 5/4. So r is 5/4. So since we actually have the sixth term, we could just divide it by 5/4 and get the fifth term. Since we're going backwards. And we get 1875 over 256. Then we have partial sums of a geometric sequence. There's only one formula. Arithmetic, we had 2 different ones, but this one there's only one. We need the first term, what our r is, and how many terms that we're actually finding a sum for. So if we have this sequence, to go from 1 to 0.6, you times it by 0.6. To go from 0.6 to 0.36, you times it by 0.6, and so on. So our r is 0.6. So our first term is 1. Our r is 0.6. We want the first 6 terms, so that's n. So sum of the first 6 terms, 1. I'm going to put the fraction in parentheses. 1 minus 0.6 to the n, to the 6, because it's 6 terms, over 1 minus 0.6. And this comes out to be 2.38336. So if we want to find this one, it says find the sum here. Well, this could really go in the calculator, truly, but we'll use the formula. Our first term you plugged a 1 in here, since it says k starts at 1, you get negative 14/3 as our first term. Our r is negative 2/3. So sum of the first 4 terms, negative 14/3, 1 minus negative 2/3 to the 4th over 1 minus negative 2/3. And this comes out to be negative 182 over 81. The difference between a sequence and a series is that a sequence stops, but a series keeps on going. So sum of an infinite series, this is the formula here. So if this sequence is going on, to get from 5 to 5/9, you times it by 1/9. To go from 5/9 to 5 over 81, you still time by 1/9. So our r is 1/9. Our first term is 5. 5 over 1 minus 1/9 comes out to be 45/8. The last one. Oh, don't do the last one. I'm not worried about it. Don't do this one. So skip all this stuff if it's in the homework, but don't do that one. And that is geometric sequences.